Okay, we are going to do 2.2. We're doing now in 2.2. We're kind of doing the same thing we did before, except now the limits are not going to one separate point. Now the limits are going to be involving this guy.
Okay, well, how do limits apply in the real world?
How do limits apply in the real world? We'll get there. Okay. So, fine. So we're looking at the x. So actually, what we're going to do is that we're going to look at the same functions that we're looking at. All right. Remember we had f of x. Now instead of this going to a certain number c, we're going to send this to either here
We did
or
this last
here.
time.
Okay.
We did this last year.
Okay. Yes, we did. We did. So let's go to page 70. In the middle of page 70, there is a green box. It says horizontal asymptote. Horizontal asymptote. Okay. So let's see if we can go ahead and use that and do example number 1. Example number 1. Limit as x approaches infinity or negative infinity. Find this. So let's see if we can find the limit of x squared plus 1 square root. So let's go ahead and graph this. Let's do the easy part first. Let's go ahead and graph it and tell me what the limit is.
You know, I would usually have 2 calculators, but I don't have my real backpack today, so.
I don't want to dig around your backpack.
So according to your graph that you graphed, when x goes to infinity, what's happening to the function? It goes to 1, correct? What about, so then this would be 1, right? This would be 1.
Okay.
What about when it goes to negative infinity?
-1.
Is it -1? Did you graph it?
I didn't graph it. I just guessed.
Yeah.
You graphed it and it goes to -1, right? Okay, so
In his brain.
question is, why does that happen?
It just
So
is.
can you see that when x goes to infinity, that this guy is going to be the same as this guy?
When it goes to infinity?
As x goes to infinity. So let's say that x is a
Yeah.
billion.
No, that makes sense. A billion plus one.
Because a billion times a billion plus 1 is basically the same as a billion times
It's
a billion.
basically, it's not like exactly equal, but
it's
it's
not.
basically.
It's a billion plus 1.
Okay, all right. Just for you, we'll put that aside. But you see that, right? Okay. So this actually becomes what? Limit of, as x goes to infinity, x over this guy.
Yeah.
And
I think.
Oh, I totally did not realize that's absolute value.
And is it no matter how big the number you're adding, it's still the same because you can just keep going bigger and bigger?
So when x is going to positive infinity, this comes out as that. Right? And that's why it becomes 1. Right? You saw that? When it goes to negative infinity, I still have this, but now the absolute value comes out not x, but as negative x. Because when x goes to negative a billion, right, the absolute value becomes a billion, which is negative x. Right? Because x was negative a billion. Right? What?
Why is it in an absolute value then?
Because it's this, this guy, which is really the same as this guy.
So then how are you turning it back into a negative?
What?
Because it's a negative x. And
So let's say that x is equal to negative 9999999, whatever. Okay?
Okay.
So the absolute value of this is what?
999.
Plus, right? So it's, I have to put a negative here to make it that value. That's where that negative comes from. So what happens here? And that's what you saw on your graph. when x goes to negative infinity, negative length. Okay?
Makes sense to me.
Let's go to example number 2. Example number 2. Okay, now we're going to look at the same thing we did before. Tanvir's favorite.
Squeeze.
Sin x over x. So if you remember this graph, what happened when it goes to infinity? It kind of oscillates and it goes to, where does it go to? Does it go to 1?
Real limit.
Are you sure? I think it goes to 0, doesn't it? Like this?
That's dampened oscillation.
Right?
isn't it?
So, let's look at why that happens. Okay. So I have sine x between what?
You're squishing it between the zeros.
1 and negative
1 and negative 1.
I thought I was onto something.
So when x goes to infinity, x is a positive number, correct? So I don't have to switch signs, correct? So as x goes to infinity, what happens to this guy?
Negative.
Really, really small. What happens to this guy?
Like equally small.
Really, really small.
It's not squished between the zeros.
The squeeze theorem, right? Remember we talked about that yesterday? The very last thing, squeeze. So this guy goes to 0. Correct? We're good there. Blah, 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 blah. Let's go to the bottom of page 71. Read the green box. And it should be the same exact thing that you looked at yesterday. So instead of going to a certain number c, we are now pushing x to infinity or negative infinity. Any questions there? And just in case Tanvir didn't get his feel of this, we're going to do it one more time. Okay? It's a little different, right? Now it's not just this, it is this plus this. Okay? As x approaches infinity. Can we see this? Right? And we know that this guy went to, right? Pretty simple, right? Because this guy went to 0, we saw the two, we did the squeeze theorem, right? So we still have the 5, right?
The limit is
5 is unaffected by x, right? Because it's just the number 5.
Makes sense.
All right, and we will stop right here today.
There you go.
Stop right here.
Yeah, that makes sense.